Okay, here we go. So, does anyone know what Apache Thrift is? Great. That was me 2 weeks ago. Does anyone know what Two Fishes is? Okay. Two Fishes is a thing by Foursquare, which I can't find now. Okay, so Two Fishes is a course GeoCoder. So you give it an address and it will return you a city or a block or a country, something like that. It's not a specific GeoCoder. It's not very precise, but it's coarse. So, and this is what we need, because what we need to do, we have address of a person and we need to match it from where they come from. We only need it like a course. All we need basically is which city they are in. So this kind of thing really helps, because all the other geocoders from Google or Yandex or Yahoo or whatever, they take time, because you have to make an API request and you get it back, and we are doing like 5,000 per second, so that doesn't really cut it. Two Fishes is basically Java. It's written in Scala, and so it's basically running on local, and you're just connecting to it, and it has a fixed database of all the addresses, or just like approximation of addresses, and it's really good. So like if you're searching for Berlin, it can return something like that to you. It can return the borders, it can return, if you're searching for whatever like street in Berlin, you're gonna get Berlin back, and then you can ask for additional stuff, like where's the center of Berlin, where are the bounds. You can get basically anything. A set is written in Scala, and it speaks Thrift and JSON. And we use this, and there was an issue that on our repo that we should probably use Thrift, because we were using JSON, and as I said, we are doing about 5,000 requests per second. So if we could do it faster, then all the better. And what they say in their documentation is that the JSON interface is slower, maybe by 20%. They don't even know, and they're the one who are building it. And the reason is that Thrift is a lower level protocol, and when you request JSON, the Thrift actually happens, and then it converts from Thrift to JSON. And because of that, it's an additional overlay, so it's always going to be slower. And this is the gem we're using, which is basically our gem, which is just gem that you specify the port where the Two Fishes is, and it connects to it, and it used to be JSON. And then I said, okay, let's make it Thrift if it's so much faster. And 2 weeks later, it's like you can see this. The Thrift is a lot faster interface, almost 2 times as fast. So, what is it and how does it work? It's a project that's now owned by Apache. It was developed by Facebook. The thing is, in the Facebook, they have a lot of languages. As you know, the primary is PHP. They also use Scala. They also Java and a lot of languages. And they need to communicate with stuff. So they have a lot of microservices that they needed to communicate, and JSON just wasn't cutting it for them. It wasn't fast enough. It wasn't, well, I don't know. They just said, okay, here's a paper that looks promising. Let's try to build on that. And the thing is, how it works, as you see, this stuff is generated. So you have some sort of Thrift code where you define how your service looks. So you define the API, you define what the endpoints are, what they're supposed to return, and all that. And then it includes a code generator, and it can compile this in basically whatever language you want. It's what they call it a service framework. It's basically XML on steroids, but it's also on a lower level. So it's more specific than JSON. You have explicit types, but it's also on a lower level, so it's much faster with much less overhead. And this is the official definition. Blah, 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 blah. C++, Java, Python, PHP, Ruby, Erlang, Perl, Haskell, C#, Cocoa, basically everything. Whatever your language is, you can, even Delphi, for fuck's sake, who's using that? You can convert you can generate Thrift code, whatever language you're using. So the main thing of Thrift is this interface definition language, IDL. It's basically, as I said, API specification. You define what kind of messages you want to receive, what kind of types you expect. You can have a validation on it. It's strongly typed because it originates from Java. And even the generated code has this Java-ish feel, but as I said, it's worth it. It's really fast. And with that Thrift code, you then generate stubs and skeletons that you use in your language. So be it Ruby, be it Java, whatever. There are some basic types: Boolean, byte, 3 different integers, double string, and then you have 3 containers that you can define, that you can use. List is basically just an array, but it's ordered, and it may contain duplicates, but all the elements has to be of the same type. Set is similar but unordered, but they have to be unique. And there's also a map, which is sort of like a hash. But again, the types have to be are fixed. The type of the key is fixed, and the type of the value is fixed. And then you have structs, which are basically like classes. You define what kind of classes that you expect. I'm gonna explain more in the demo later. So yeah, you define this Thrift file where you have this interface definition. You use a compiler, and then when you have this underlying code that you can use. So you have this on server, you have this on client, and no matter what language they are, they can easily talk to each other. So there's a tutorial on Apache, which looks really weird, and it's not really that good documented. I guess it's not used that much. But the point is, you download these tutorials, which I'm going to show, and then you can generate the files. So the files, no, this is not it. This is it. Looks like this. This is the tutorial Thrift file. There's a blah, 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 license, blah, blah, blah. And then you have some namespaces. And then you define, okay, my integer is going to be an integer. You have some constants. So basically what tutorial is API for a calculator service. So you're going to have server, which is going to calculate, and you're going to have client, which is going to send stuff to the server, which will then calculate stuff. So you have a struct named work. Can you see this? Right? Bigger. Make it bigger. You have a struct named work, which accepts 2 numbers, and operation. Operation, as you see, is a class, and it's then that was before defined. It can be add, subtract, multiply, or divide. This, by the way, is Thrift file. So this is the underlying file that then converts to whatever you want. And then you have a service. As you see, we have ping, we have add, we have calculate, and void. This is just a simple thing. And what you then do is you go into the correct folder, and you say or not. Thrift dot generate dash gen RB is the language, so we're compiling into Ruby, and this is the Thrift file. When I press this, I have some warnings because God knows what, but I got this folder gen RB. And you can see in there you have the calculator. So this is the service that was before defined, which is now a module. It has a ping method, it has add method, it has calculate method, and zip method, like we defined it. But these are the generated code. So there's send ping, there's receive ping, there's send that, there's receive that. Everything is very generic. You can see it's generated code, but it's how it works. And you also have the constants, like we defined before, and the types. So the operation is now a module, so basically you have constants in there. Work is now a class, and so on. But this might be confusing, but thank God they also have this nice thing. If you say, I want to generate into HTML, well, that's of course not the language, but what you get is documentation, auto-generated documentation. You get the stuff from tutorial and the stuff from shared. You got listed all the services, all the data types, and you say, okay, like looking at calculator, and we see it has ping, it has add, it has calculate, and void. And we say, okay, we want to use calculate. What's this work stuff? We can just click on it, and we see, okay, it expects the numbers. It expects operation. Okay, what's operation? Just click on it, and there's add, subtract, multiply, divide. I'm not gonna live code this, but I'm just gonna show the code that I previously have done. The server is basically just says, okay, you require Thrift, of course. It's a gem by Apache also. So this is the underlying connection stuff. You initialize it, and for ping, you say, okay, we just put ping. Basically, you have to use the same names as we used before. So ping, add, calculate, and zip. And then we define a handler, we define a processor, or whatever, and then we serve this server. So this is what I'm gonna do now. Just run it, and it doesn't work. Shared service. What? Huh? Require cannot load such one. Yeah, nie mam bundle. But this worked before. Push okay. Huh? Yeah, Jackie. Shankrat. This is the same. Nah. Shard types. Oh, okay. Ja tega fajla sploh ni, čak. Mi ne sramiče. Oh, no point. No one's using this. Oh, yeah, here we go. Yeah, starting the server. And we also are gonna have a client. So what the client does is you tell it the port where the server is running. You open a transport protocol in client, which comes from the gem, and you open transport. Then you ping. What we're gonna do? We're gonna ping it. We're gonna add 1 and 1, and we're gonna print the sum. So the server will calculate this. And then we have operation subtract. Basically, the server will do this work. So this is just like to show how it all works. So if we run now the client, yeah, Jesus Christ, seriously. Server. I hate it when stuff works at home, but not here. So 1990, it should be fine. Seriously. Не вам работать. Yeah, have no idea what's going on here. Anyway, yeah. If you want to know more about Thrift, I'm gonna put these slides up. Oh, no, they're already up. This was basically before Lightning Talk, which just became a talk because no one else wanted to do a talk. There's a homepage which isn't really useful. There's the missing guide, which is a bit better because they realized the homepage sucks, so they made their own guide. And there's a really good talk from RubyConf 2013 where they used Thrift to build their own microservice architecture. and it's pretty good. And he knows much more than I do about Thrift, and explains it nicely how it actually works. And yeah, I have no idea why it didn't work now, but that's life. It's fine. It's fine. Okay, doesn't matter. Anyway, yeah, so this then got merged in. These were just the preliminary results. I was just trying this with some pseudocode, more or less, and it turned out to be much faster. So I said, okay, let's do it. And in the end, now we have lowered the response time from about 3 milliseconds to more or less 1. So we're really satisfied with this. It's really fast. It works fine. The generated code is a bit ugly. So the two fishes client is a bit bigger. I can show you that. So the Thrift files for GeoCoder look like this. There's much more code, and the types are very specific. And so the end code looks like this. Instead of just requesting GeoCode with query, you have to first build a GeoCode request, which is a class, and then you pass this class to GeoCode, and then you get it back. And what you get back is then oh yeah, we did this in the result. You get a response back, which is basically a class, and then you can do stuff on it, and you can look into then again here, and you need to find the GeoCode response, and it's really sucks because it's all in one file, so it's like 400 lines of code, of generated code, and you have to find your way around it. It's really not that good documented, but with that HTML hack, you get at least some sort of documentation, so it's better. Anyway, any questions?
What does the format of the actual communication look like?
You don't have access to that because it's done on a lower level.
Is it like binary?
Yeah. It's binary. It goes through the regular ports, but it's not HTTP. It's binary.
So custom.
Yeah, it's a custom protocol.
Does then these classes in Ruby then include the binary data and parse it?
No, the gem does that. So the Thrift gem by Apache actually does all this heavy lifting for you. So you don't even know what's going on.
But is that done in Ruby, or is that
Yeah.
system component?
No, it's a Ruby gem that does this. So you open up a client, which is like here, Thrift client. You say what's your class. So GeoCoder client is our class in this case. You give it an address, and there's a lot of options you can pass in. But what we do is just retries and timeout, and you have this client. And to this client, you can then send all the methods that this client, so this is generated client, GeoCoder client, and it has geocode, it has reverse geocode, it has bulk reverse geocode. So all the classes all the methods that were auto-generated can then be used, and you just pass it to the client, and this, you can see what you're going to get back.
And so a method then represents, if you want to compare this to JSON, a method represents an attribute?
An endpoint.
Huh, okay.
It's like
So it's more like, would it be better to compare it with the rest?
Yeah, that's it. Here the geocode is basically it's like an endpoint. So if the endpoint would be, I don't know, /geocode, and you would send a query to it, and you do it this way, that you first build up a geocode request, which is what this geocode accepts, and then you pass it into geocode. Yeah. It's very, I wouldn't do this if it wasn't so fast. Like the only reason we're doing this is because it's almost 2 times as fast, and in our case, it's definitely worth it. But I would stick with JSON if I would do simple things. But when there's a performance question, I would look into this.
What happens if you have 2 different architectures?
Doesn't like.
Does it work with the message passing?
Yeah, that's the whole point. That's why Facebook invented this. It's on paper from them.
Processor architecture. If one is
Oh.
on ARM and the other
I don't think it should matter, because if it compiles down from language, it should work, and it's basically still uses the same network. What is it? Yeah, so I guess it should work normally, as long as you use a language that this thing compiles to. And seriously, the language list is really long. Basically, anything that has some sort of class, that knows of some sort of class, you can easily use that. So.
Who else is using this?
Facebook, by and large, Twitter internally. Then Foursquare uses it a lot internally. I think it's a thing that you don't necessarily expose to public, but optimizing like internal stuff, this is where you look. Because especially now with these microservices being really popular and stuff, JSON is probably not the fastest way to communicate with them. So I guess it's more for like internal stuff. If you have a lot of, like I said, this talk on RubyConf is really good. How they did it. They got a lot of microservices, and they decided for Thrift to connect them together because they had the same thing. The JSON wasn't fast enough, and with JSON you never know what you're gonna get. So you have to first parse it to know if it fits what you're actually expecting. Whilst here, if it's not the right class, if it's not the right thing, it's just like it doesn't validate, and you don't even get it. Yeah, but it's not really new. It's been around for a while. I didn't knew about it.
I remember because in university we did the Java, WSDL thing, and it also works very similar. It also creates the client class where you and then you use it.
But yeah, that's the SOAP stuff basically, right?
Yeah, it's really similar.
Yeah. There's a explanation on Wikipedia and on the homepage why they did it this way, and on which paper it's based on. And yeah, like I said, it was developed internally on Facebook, and they thought it's worthwhile sharing, and then Apache took over, and it's now called Apache Thrift. There's also some variation. The thing Twitter uses internally is called Flint Thrift or something like that. I don't know exactly what the differences are, but it's the same thing that Doofishes also uses. It's backward compatible, but not entirely the same. I didn't go into details. As said, 2 weeks ago, I had no idea what Thrift was, and now we're using that in production. So, great. Yeah.
One more question. Can you write server and client code yourself and use Thrift just for encoding and decoding data?
You probably could, yeah. But the thing is that the whole point of Thrift is that you have this definition in Thrift language that you can compile to whatever. So if you decide to have a new service, just add it there, and then you simply compile in all the languages that you're using this, and bam, it's back. So maybe it's not the best thing if you're just doing it in one language. If all you do is Ruby, it's probably Thrift isn't the best choice. There are some other binary protocols, but if you have a very diverse language-wise architecture, then it's probably a good thing, at least to look at, if not use. Do we have any lightning talks?
Yes.
Come. Okay, thank you.